Assalamu alaikum. We know a charge produces electric field around it. This we have studied in the first chapter of 12th physics, that is in electrostatics. When there is a charge exists, whether it is a positive charge or negative charge, both have electric field around it. And this electric field appears something like this. Suppose if I have a positive charge, I consider this one as positive charge, then we may find this comprising of a electric field acting the outward direction. So these lines are nothing but electric field lines. They constitute electric field. Okay, so a positive charge produces electric field whose electric field lines are acting outward. In the similar way, another type of charge, which is nothing but negative charge. When we talk about a negative charge, it also have a electric field around it. And in this case, the electric field act towards it. Just the opposite direction of the positive charge. Fine. So these dotted lines that I am drawing here represents the electric field lines which acts towards the negative charge. Clear? These electric field lines as a whole represents the electric field. So from this it is clear that a static charge the static charge means charge at rest. Now here static means at rest. So a charge at rest produces electric field. It produces electric field. No? This is quite clear from this two diagrams. Now, what happens when these charges move? If these charges starts moving with a certain velocity, some uniform velocity in a particular direction, in such case they constitute electric current. Now suppose I have a charge Q moving in this particular direction in a straight line, then it will constitute an electric current. Electric current is given as rate of flow of electric charge through a given conductor. Okay, it constitutes electric current. Fine. So what is the condition here? Charges must flow in a particular direction with some velocity. If this velocity is uniform means do not change its magnitude during a given time. Okay, if it is so, then the current here is referred as steady current or direct current. Okay, fine. Now when one such electric current flows through a conductor, then it is found that the conductor produces magnetic field around it. Okay, so when electric current flows through a conductor. What is conductor? Conductor is anything which allows current to pass through it, is referred as conductor. When electric current flows through a conductor, it produces magnetic field. Okay, here magnetic field is represented letter B. Electric field is represented letter E, and magnetic field is represented letter B. It has got direction as also represented by this arrow mark on its head, which shows that it is a vector quantity. Clear? So from this it is clear that when charges are at rest, they produce electric field. When they start moving in a particular direction in a conductor, it constitutes electric current. Due to the flow of current in a conductor, it produces magnetic field around it. Now, when these charges starts accelerating, when they accelerate, it means their velocity is increased or reduced. I think when the velocity of these charges changes when they move in a conductor, in such case, here along with electric field, they also produces magnetic field. So, when charges accelerate, when they will accelerate, when their velocity changes, then they will accelerate. When charges accelerate in a conductor, you can take it as a wire. The conductor, it produces magnetic field along with electric field. So, as a result of this, we get the electromagnetic waves, which is the combination of electric field and a magnetic field. Okay, when E and B combine, we get electromagnetic waves. So remember this, we get electromagnetic waves. EMW stands for electromagnetic waves. Fine. So here, how does this electromagnetic wave look like? Let me show this to you with the help of a simple diagram. Here, I take a coordinate system. Okay, axis, two axes, x-axis, y-axis. I take electric field along this axis. This one is the electric field. Okay. Now here, this wave represents the oscillating electric field. What is this? Oscillating electric field. I represent letter E vector, oscillating electric field. Then we should also have magnetic field here. This magnetic field is taken along this direction. See. Okay. This is the magnetic field. I take this one as magnetic field, which acts just perpendicular. If electric field act along x-axis, then magnetic field will act along y-axis, perpendicular to each other. Remember this. If it is so, the combination of these two, which is nothing but electromagnetic wave, will propagate, will travel in a direction perpendicular to both electric field and magnetic field. Okay, and here I'll do one thing. I draw few lines here with the arrowhead. These lines, they represent the electric field vectors. What do you call them? They are referred as electric field vectors. Okay, electric field vectors. In a similar way, now these lines will just act perpendicular to this orange line. Now they represent magnetic field vectors. Now just from the diagram, it is quite clear that they act perpendicular to each other, and the combination of these two acts in a direction perpendicular or mutually perpendicular to both electric field and magnetic field. If electric field vibrate in this direction and magnetic field vibrate in this particular direction, then the electromagnetic wave will act along a direction which is perpendicular to both the electric field and the magnetic field. See, let me show this to you with the help of a simple example. Suppose here I have three pins. Now I place them in such a way that they are perpendicular to each other. Now see, this red pen and a black pen are perpendicular to each other. Now here I include this blue pen. Blue pen is mutually perpendicular with black pen and a red pen. Okay, mutually perpendicular means it is perpendicular to black pen, and also if you see, it is perpendicular to this red pen. What is the meaning of perpendicular? When two things make an angle of 90 degree with each other, then they are said to be perpendicular to each other. Okay, suppose the electric field act along red pen and magnetic field act along black pen, then the electromagnetic wave will travel along the direction of this blue pen. Okay, this is what it means, this diagram means. Got it? Now, being a wave, it has got two kind of oscillations. Electric field oscillates and magnetic field also oscillates. So, mathematically we can represent by some equations. Here I use E to represent electric field. It can be taken as E naught sine of kz minus omega t. This is the equation used to represent a sine wave. Then this kind of wave is called as sine wave, and the sine wave is represented by this equation. Okay, then the magnetic field is represented by an equation just similar to the first one, but what we do here, in the place of E we write a B. Okay, here E stands for electric field, B stands for magnetic field. Now suppose I say that electric field act along x-axis, so in the place of E I take Ex, and if I consider that magnetic field act along the y-axis, then I will replace B with a By. Now what these terms represent here? Here E stands for amplitude of electric field represented by the sine wave, and B naught stands for amplitude of magnetic field vector. Okay, so this two represents amplitude. B naught represents amplitude. What is this amplitude? That I will tell you. Okay, and here K stands for wave number. And omega here represents the angular frequency. Omega stands for angular frequency, and T stands for time. T stands for time. Okay. Now let me tell you what is the amplitude, wave number, and angular frequency. Now for that I must take a wave. This one is a sine wave. I'll just extend this. Now here, it moves upward, then comes downward, and it is continued in the opposite direction. And then it continues the same pattern. This kind of motion is referred as oscillation or vibration. Okay, clear? So this represents oscillation or a vibration. Correct? Now you see here, this yellow line represents the mean position here. In this case, mean position. See, a particle started from here and goes to its extreme end. No, maximum displacement is reached by the object when it reaches this point. Then it returns back to its starting point, to this line, which represents the mean position. Then it moves downward to its extreme end again in the opposite direction. Then it goes back to mean position. Now it starts from one point and returns to the mean position. So this kind of motion, when something moves from one point and returns back, the same point after traveling certain distance. Means we call this as oscillation. What do you call this? Oscillation or a vibration or a vibration. Okay. So in this case, in case of this wave, now usually to represent wave we use this diagram. Height of the wave. Height of the wave from its mean position is taken as amplitude, and here the distance between two consecutive points. Now see, I take this as a consecutive point, these two as consecutive points which are of a same type and placed one beside the another. Distance between two is taken as wavelength. You can take any two consecutive points. If you want, you can take these two consecutive points. These two can be taken. Take these two again. The distance between these 2 points is referred as wavelength. Okay. Then wave number. To know what is this? Wave number is nothing but number of waves. The given length. Number of waves per unit length. Let us speak number of waves in a number of waves per meter is referred as wave number. Then angular frequency, how many times the particle oscillate in a given time is referred as angular frequency here. Got it? That's all about the terms present here in this equation. Okay. Now, as I told you here, E and B acts perpendicular to each other and they move in a direction perpendicular to both of them. Okay. So, which represents the direction of propagation of electromagnetic waves. Now I'll go ahead. Now we'll discuss about the velocity of electromagnetic waves. Now here, the ratio of E naught and B naught gives us the velocity of electromagnetic waves. Velocity of electromagnetic waves. Okay. The velocity of electromagnetic wave can be taken as C, which is equal to E naught upon B naught, and it is found to be equal to 3 into 10 power 8 meter per second, which is the velocity of light. So, electromagnetic wave travels with a velocity of light in a vacuum, in a free space. But when it starts traveling in a medium, in a medium, the velocity of electromagnetic wave is less, and I represent it by letter V. See, letter V. So this clearly shows that V, because I represent letter E upon B. Electric field vector in a medium and magnetic field vector in a given medium. So V is always lesser than C. This is what we understand. It shows that electromagnetic wave travel with low velocity in a given medium compared to that in space or free space or vacuum. I hope the video is useful. If you have any kind of doubt relevant to the topic, can you put your question in the comment section. Thanks for watching.